Bismillahirrahmanirrahim. Today, inshallah, we are going to discuss the three-phase circuits. Just a quick review. For three-phase, we have three-phase supply and three-phase load. So the three-phase supply is already coming from power stations. The majority is coming from synchronous generator, and this is the shape of synchronous generator. This is a rotor circuit, and here is the armature circuit, which consists of three phases like that: phase A, phase B, and phase C. And it can be connected in two different ways: either star connection or Y connection. We call it star or Y, and delta connection. As you can see, it's nothing but three single phases. So we have phase A, phase B, and phase C. However, when we connect these three sources in this configuration, connecting the ends of all of three coils together in a point called the neutral point, we call this connection is Y connection or star connection. In this case, the voltage for each coil will be named as phase volt, and the volt between two terminals, A and B, or B and C, or C and A, will be called line-to-line volt. So we have two different voltages here: phase volt, which is VAN or VBN or VCN. This is called the phase voltage, or sometimes called line to neutral, because it's a voltage between line and the neutral. Or we have the other volt, which is the line-to-line volt, or called coupling volt sometimes, which is VAB, VBC, and VCA. So these are the different two voltages here in the circuit in case of star connection or Y connection. So what are the features of the three phases? The features that all of the three phases have the same RMS value, and all of the three phases are operating at the same frequency, which is depending on the rotation of the machine. So all of them are have the same frequency. And a very important thing is that there is a phase shift between each phase, phase shift of 120 degrees. So in case of a star connection, we can represent the sinusoidal waveforms in these expressions: VAN equal V maximum sine omega t, VBN equal V maximum sine omega t minus 2 pi divided 3, which is 120 degrees, and VCN equal to V maximum sine omega t minus 4 pi divided 3, which is 240 degrees. So we can say minus 240 degrees or plus 120 degrees. Okay, Shabab? If we would like to represent this in phasor diagram, as you can see, VAN is the phase voltage at angle 0, VBN is at angle minus 120, and VCN at angle plus 120. If you would like to calculate the line-to-line voltage from star connection, we can return back here again. Line-to-line means between A and B. So how we can calculate VA and B, Shabab? We can make loop, is it right? And just a moment to attend your colleagues. How we can calculate the terminal voltage VAB? Simply can make a loop, okay, or make Kirchhoff voltage law between points A, N, and B. So we can say VAB equal to VAN minus VBN. Okay, so simply if you subtract VAN minus VBN, so this is VAN, VBN is this vector, so minus VBN, we can draw
دكتور انت توك بديت ولا؟
I started يعني 5 minutes.
لانه جاي يقول لي من اول انا داخل يقول لي waiting room.
ما انا ما شفتش الاسماء غير دلوقتي. Okay. Let's continue شباب. VAN minus VBN. So minus VBN means the vector in the opposite direction of VBN. So it's expected to be in this direction. So this is minus VBN. If you would like to add the two vectors, the resultant vector will be the value of VAB. So VAB represents the line voltage, and there is a definite relation, which is VAB as a magnitude equal to square root of 3 multiplied by the phase voltage, and the angle is shifted by 30 degrees. So if you would like to get VBC as a function of VB, it will be the same. VB as a magnitude multiplied by square root of 3, and you have to add 30 degrees, and so on. Okay, شباب?
Can you repeat?
Again, how to calculate VBC? VBC equal to VB minus VC. So VC will be in that direction, VCA in negative will be in that direction, and the resultant vector will be VBC. So in order to calculate the three phases, what we can do, you can just calculate the first one, VAB, like we have made now, and we got that VAB equal to square root of 3 multiplied by V phase. So square root of 3 multiplied by V phase, which is V maximum, divided by square root of 2. And we can add 30 degrees on the angle of VAN. So VAN at angle 0, add 30, so it will be at angle 30 degrees. The same is also for other line voltages. So for VBC, how we can calculate VBC? VBC equal to VBN multiplied by square root of 3 and add 30 degrees to minus 120. So the result will be square root of 3 multiplied by V maximum divided by square root of 2, which is V phase magnitude, and the angle equal to minus 120 plus 30, which is minus 90 degrees. طبعا يا شباب يعني because it's equal phase shift between all of phases and lines, so we can only calculate the first one and just shift of 120 degrees. So if VAB at angle 30 degrees, so VBC will be at angle 30 minus 120, so it's minus 90 degrees. Then VCA equal to the same value of line voltage, and the angle will be 30 plus 120, so it's 150 degrees. So generally, if you would like to get V line from V phase as a magnitude, you have to multiply by square root of 3. And as a vector, VAB equal to square root of 3 multiplied by VAN and add 30 degrees to the angle of VAN. Okay, شباب? This is for what's called the ABC sequence. ABC sequence, which means if you are standing here in this point, okay? Here, if you are standing here at this point, you will see VA moving in that direction, then after that, VB, and then VC. So it's called VABC sequence. It's called ABC sequence. But if the sequence is reversed due to reversing the motion of the generator shaft, this can reverse the sequence of the supply, and it's called ACB. So A coming first, then C coming after A, and then B coming after C. It's called ACB, which is this shape. So ACB, this is the second sequence, ACB sequence, and the relations will be like that. AN at the same angle, 0. However, VCN at angle minus 120 and VBN at angle minus 240 or plus 120. Similarly, we can compute the line-to-line voltage from phase voltage. You have to multiply by square root of 3. However, here, because the sequence is reversed, so you need, when you get VAB, you need to subtract 30 degrees, not from VAN. You need to subtract 30 degrees from VAN, like the last example. It's the same, okay? But because we said here VAB, not VAC. ماشي شباب? So VAB can be obtained in the same way. So you can memorize this relation for either for ABC sequence or ACB sequence. VAB equal to square root of 3 multiplied by VAN at angle theta VAN minus 30 degrees. Okay يا شباب؟ Any question?
دكتور يعني تقصد
اتفضل.
في السلايد اللي قبل
Yeah.
نحفظ الرسمة دي نفسها اللي في اليمين كلها ولا
يعني ما فيش حاجه بنقول نحفظ، انت افهم بس الايه، لان انت هتحفظ ايه ولا ايه، لا انت يعني لازم تكون فاهم ازاي بتستنتج الفيزور دياجرام من الريليشنز بتاعتك، وتكون فاهم ايه العلاقه بتاعت الاي بي سي سيكونس والاي سي بي سيكونس.
لا أنا أقصد واحدة منهم يعني تحتاج رسمة واحدة ما أحتاج الاثنين صح؟
والله ارسم واحده والثانيه هتبقى معروفه ان هي عكسها. يعني انت دلوقتي الاي بي سي اهو، الفي اي بعد كده الفي بي بعد كده البي سي. خلاص لو هتشتغل اي سي بي سيكونس خلاص يبقى اتفهمت، يبقى اي سي بي وهكذا، وتقدر تعمل ديريفيشن لنفس الريليشنز. ماشي. ده شباب بالنسبه this is for star connected source. This is for star connected source. طب what about delta connected source? We have another connection called the delta. As you can see, if the three phases are connected in that shape, either load or sources, okay, this is called the delta connection. Okay, delta connection is simply we connect the end of the first coil to the start of the second coil and so on. And we can draw it outside like that. If you have three coils like that for the three phases, and you need to connect as delta connection. So for the connection, let's change the color. So start from the start of the first coil to the end of the second coil, and start of second coil to end of third coil, start of third coil to the end of first coil. So now we connected the three coils in delta. However, from where we can connect the supply, we can connect the supply from either ending or starting terminals. So this will be A, this will be terminal number B, and this is number C. Is this clear يا شباب? So this is the meaning of delta connection. طيب. So for delta connection, شباب, for delta connection sources, if it is ABC sequence, so we will assume that VAB has magnitude of V line and at angle 0. So VBC, the second line voltage, will be V line at angle minus 120, and the third voltage VCA equal V line at 120 degrees. Take care that in a star connection, if we return back to star connection, here the line voltage is different to the phase voltage. Is it right? And we got the relation, it's √3 multiplied by the V phase. However, here in delta connection, the phase voltage is the same as line voltage because phase means the coil of the machine itself. So for phase A, we can say phase A as voltage equal to VAB because it's in parallel with it. Is it right? So in delta connection, V line and V phase are equal. However, I line and I phase are different. So the current which is moving here, we call it I line. This is I line A. It's different to the current which is moving here, which is called IAB. Okay, شباب? So IAB is phase current and I line is line, IA is line current. تمام? So in delta connection, phase and line currents are different. However, in star connection, phase and line voltages are different. Okay, شباب? طيب. So this is for ABC sequence. However, in some problems, we need to simplify the circuit. We are not going to use the circuit as it is. We can convert it to single phase and start solving it because we are going to work with balanced three-phase circuits. So it's better to convert delta connection to a star connection. It's possible, just to know the relation, how to convert from delta to star, and know the relation of the equivalent star. So simply, if this is the line voltages, we can convert to a virtual star. We are not going to reconnect the machine. The machine is already wounded, but we are going to virtually assume that we can convert this delta connection to star in order to solve the mathematical equations and the circuit easily. So simply, we can assume that we have equivalent star like that. And as you can see here, we have VAB, VBC, and VCA. And the equivalent internal star will be VA, VB, and VC. So what are the values of internal star voltages as a function of delta voltages? So simply, we can calculate VA equal to V line divided by square root of 3, and the angle will be shifted by minus 30 degrees. Okay, شباب? Simply, we can make the same for VB and VC. Sorry, this should be VC.
So,
this is VC يا شباب. Screen?
No.
Something happened. Now you can see?
No.
Yes.
Okay.
Doctor, all of them ABC sequence in this slide.
Sorry, it's another type of error.
Okay.
Okay. So this is the three-phase voltage in terms of three-line voltages. The same also for the ACB sequence. If we have VAB at angle 0, VCB at angle minus 120, VBA at angle 120, so the equivalent star can be driven in the same way. Okay, شباب? So this is how we can convert delta to star in order to solve the problem easily. Now, this is for the sources. What about loads? For the loads, it's similar. If we have star connected load like that with 3 impedances, we can say the load is balanced if ZA, ZB, and ZC are the same. So if ZA, ZB, and ZC equal to Z phase or ZY at angle theta, we can say that IA equal to simply equal VA divided by ZA. So the magnitude will be I phase at angle minus theta, which is the same angle of the impedance. And similarly, we can say that IB equal to the same value of the phase current, because the voltage and the impedance are the same magnitude, and the angle only will be shifted by minus 120 and plus 120. So this is the relations of IA, IB, and IC. Note that for star connection, this is the impedance of the load. What is the relation between line current and the phase current? And if we make the phase current in a box, and if we make a box here on the load, so this is the line current here, here, and here. However, in most of connections, for the 3 wires for a star, if it is 3 wires, not including the fourth one, and we can consider that this is black box and we have only 3 terminals, IA, IB, and IC line currents. What will be the value or the relation between the line current, IA, according to the value of the current moving in the impedance here, which is I phase? What is the relation between line and phase current, Shubin?
equal.
It's equal.
same.
صح تمام.
Same.
But in delta it was not equal. تمام. So in delta connection, currents of phase and line are not equal. However, in star connection, voltages of phase and line are not equal. تمام كده؟ طيب. So this is the relation between currents. If we need to calculate the power, simply we can summate the three-phase powers for the three phases. And we assume because we have identical phases, so the summation of power will be 3 multiplied by the power of single phase. So the power of three phases can be calculated as 3 multiplied by VBIB, which is V phase root mean square, I phase root mean square. So this is V phase RMS value, and this is I phase RMS value. طيب, what about cosine theta? What is the theta, شباب? What is the angle theta?
The difference between the voltage and the current.
Which voltage and which current? This is a very important question in three phase, because in single phase we have only one phase voltage and one phase current. However, in three phase we have three voltages and three currents, and may have extra. يعني if we have phase and line voltages or phase and line currents, so you have 9 different quantities. So what is the value of theta? Depend on what?
The phase
Or
voltage.
line or what? All of time يا شباب, power factor is cosine the angle of impedance. So theta is the impedance angle. Theta is the impedance angle. Type impedance angle, which means you can calculate it from theta. You can calculate it as theta volt phase minus theta current phase. صح يا شباب? Because we said before, phase means the coil itself, صح? The impedance itself. So this is the theta what we need to calculate in power. Okay, not the angle between any voltage and any current. لا. It has to be phase voltage and the phase current. Okay. So the power of the three phases, as we agreed, it's three phase I phase cosine theta, and also can be expressed as a function of V line and I line. For a star connection, شباب, what is the relation between V line and V phase? Write on the chat, please. What is the relation between V line and V phase in star connection? يا شباب. الناس معايا ولا لا؟ Square root of 3, تمام. Okay, so we can say now V line divide square root of 3 equal V phase. So we can replace this relation by V line divided by square root of 3. And also in star connection, I phase and I line are the same. So we can say now the power equal to square root of 3 multiplied by V line, I line, cosine theta. Take care, cosine theta all of time will be the angle between V phase and I phase. Okay? طيب. جميل. Is it valid also for delta connection يا شباب? Square root of 3 V line, I line, cosine theta. Is it valid also for delta connection? Let's assume we have delta connection. For delta connection, I line equal to I phase multiplied by square root of 3. So if you would like to substitute here, we can say that 3 equal to square root of 3 multiplied by square root of 3. So square root of 3 multiplied by I phase equal I line. So we can say also in delta connection that the power equal square root of 3 V line, which is the similar to V phase in delta connection, multiplied by I line cosine theta. So finally, we have two different relations. We have the relation of 3 V phase I phase cosine theta, or square root of 3 V line I line cosine theta can be applied on delta or star. Similarly, we can calculate the reactive power. However, we should replace cosine theta by sine theta.
So I phase is equal to I line, right?
In a star connection, V phase equal I line. In delta connection, sorry. In a star connection, I phase equal I line. In delta connection, V phase equal V line. تمام؟
دكتور
اتفضل.
سوري انت تكلمت عن ثيتا وقلت انه هو حق الزاويه بين الامبيدنس، بس ما فهمتها هنا. يعني we have three voltages. Yes, well, which one?
But
What is theta?
In the beginning of the derivation, we said that ZA equals ZB equals ZC. It's a balanced three-phase load. So all have the same values and the same angles. So theta is the angle of any one of them.
Okay.
Okay?
Yes, thank you.
Okay. For delta connected load, Shabab, if we have delta connected load like that, also the three phases impedance will be equal. So ZAB equals ZBC equals ZCA. And the currents magnitude IAB, IBC, and ICA also will be equal. So simply, we have IAB here, IAB equal to VAB divided ZAB. And you know the relations, VAB equal V line at angle 0, VBC equal V line angle minus 20, VCA equal V line angle 120. So when you would like to calculate the current, simply divide VAB by ZAB. So it will be V line divided Z delta at angle minus theta. So it's equal to I phase at angle minus theta. So this is IAB. If you calculate IBC by the same way, you will find that the value will be I phase at angle minus theta minus 120. So it's the same shifted by 120 as in a previous case of star. The same also for the third phase, ICA equal I phase at angle minus theta plus 120. Right. If you would like to calculate the line current now, simply, if you would like to calculate IA, just apply Kirchhoff current law at node A. Just apply Kirchhoff current law at node number A. So we can say that IA plus ICA equal to IAB. So if you would like to get IA, it's equal to IAB minus ICA. Here in the phasor diagram, this is IAB. We need ICA. This is ICA. So if you would like to subtract IAB minus ICA, this is minus ICA. So the sum of these two vectors will be IA, which is the line current of phase of terminal A. So as you can see, the line current is shifted also by 30 degrees, and the magnitude will be also square root of 3 multiplied by the phase current. So simply, you can multiply the phase current by square root of 3 and shift the angle by minus 30 degrees. So IA, which is the I line, equal to square root of 3 multiplied by I phase at angle minus theta minus 30 degrees. Okay, شباب? Right. The same is also can be made for IB and IC. For the power calculation, yani we agreed together that delta and star connection have the same configuration for calculating power. You can calculate it using 3 V phase I phase or √3 multiplied by V line I line. And all of time, the cosine theta is the cosine of the impedance angle. Okay. The same also for Q. However, Q is dealing with sine theta instead of cosine theta. And similarly, we can calculate the S, the apparent power for the 3 phases. Okay. If we have delta connected load and we need to transform this delta connected load to star in order to simplify the solution and make analysis, what we can do is like that. If you have 3 equivalent impedance, 3 equal impedance in delta, simply you can assume virtually that you connect them in star, like that. So Z star or ZY equal to Z delta divided. Any question يا شباب؟ يا ريت اللي فاتح المايك يقفله. طيب. So this is the transformation from delta to star. طيب, if we are going to make it as per phase equivalent circuit, and let me show you in the star connection load here. Yeah, here. Can you see ZA and source VA? It's connected in parallel, is it right? So simply you can calculate the current moving here. However, if the connection of the source here is delta, is it possible easily to calculate the current IA? It will not be that.
Not that easy.
So we have to convert from delta to star. And when we convert from delta to star, we need only to calculate one phase. So we are going to apply circuit analysis for one phase. And for other 3 phases, we are going only to shift the angles. This is all. Is it right?
بس يا دكتور جينا نغير بس نغير virtually ما نغير في الصدق يعني.
Exactly. All of the conversions here are virtually. Virtually mean you are not going to reconnect the supply or reconnect the load. Okay? So returning back again to the per unit. So for per unit, it's better to convert from delta to star by getting Z star equal to Z delta divided 3 and converting the supply from line to phase, line to phase, which is calculated by VAB, which is V line, divided by square root of 3 and subtract 30 degrees from the line voltage angle. Okay, so this is the steps in solving in per phase equivalent circuit. Right, let's have solved example in order to recognize how we can use this in 3-phase circuits. Assume we have 3-phase balanced system shown in this figure, and there are here some devices we are going to discuss maybe next class, inshallah. The load is Z equal to 8 plus J6 ohms. طبعا plus J شباب, it means this load is inductive or capacitive?
It's inductive.
Inductive load, exactly. And consider VAB, which is the line voltages here from A to B, equal to 200 at angle 0. طبعا يعني all of time it will be RMS value. يعني all of time the voltage is given as RMS. And the phase sequence is AB and phase sequence A, B, and C. يعني the expression is not good in the reference. It should be stated ABC sequence. Okay, fine. What is required here? To find the phase currents. This is number 1. And as you can see, it's said here phase currents. Phase currents, it means phase current of first phase, second phase, and third phase. Okay, so just you can calculate one phase and after that shift the angles to get the 3 phases. Also, it's required to calculate the line currents. طبعا here, because of the delta connection, the line currents will be different to the phase currents. Also, find the total three-phase power. Calculate the power for the three phases. Draw the phasor diagram and of currents and voltages together, and calculate the reading of W1 and W2. And this part will be discussed next class, inshallah. So we need now to calculate the first or solve the first requirements. So start from the beginning, Shabab. In order to solve now, can we solve using delta or star? Hey, Shabab. The load is delta and the given supply is line to line. So do we need to convert to star or not?
No, it's VAB over Z.
Exactly. It's very easy to solve here on using line voltages. We have the line voltage and we have the impedance of the line because it's delta here. Is it right? So simply we can say IAB equal to VAB divided by the impedance. Again on the circuit here, IAB equal VAB, the voltage between these two terminals, divided by the impedance Z. So it will give me the value of IAB. And similarly, we can shift the angles to get IBC and ICA. So we don't need to convert here. So simply, IAB equal to VAB, which was 200 volt, divided by impedance, which is 10 at angle 36.9. And this is after converting from Cartesian to polar form. And this is the value of the current now, 20 at angle minus 36.9. If you would like to get IBC, you don't make all of these calculations. You just need to say the current is 20 amps and the angle is just subtract 120 degrees from this value. So it will be minus 156.9. So this is the IBC. If you would like to get the ICA, get the angle of IAB and add 120 degrees. So the current will be 20 at angle 83.1. So this is the three-phase currents. Any questions, Shabab, in this part? Is it clear?
Clear, Doctor.
Yes, clear.
Good. What about line currents? I would like to get the value of IA. How we can get it? And let me ask you
Kirchhoff.
to see if people are
كيف لو دكتور؟
following
Doctor.
me or not. Abdullah Al-Hazmi معايا ولا لا؟
ايه معاك دكتور.
قول لي عبد الله اجيب الاي ازاي؟ How to calculate the line current?
We can use Kirchhoff law.
Kirchhoff, which one? Kirchhoff voltage or current?
Current.
Current, exactly. طيب احمد الغامدي.
Yes.
ابو حميد طبق لي كده Kirchhoff current law at node A. Apply Kirchhoff current law at node A. So what will be the value of IA? IA should be ابو حميد.
Yes, wait. IA
equals
IB plus minus ICA.
لا, someone else. خلينا نشوف علي المنشد.
ايوه يا دكتور. IAB minus ICA.
IAB minus ICA. Exactly. This is right. So you can calculate it using this way, or you know previously you can say that I line equal to square root of 3 multiplied by I phase. Okay, and the angle should be shifted by minus 30 degrees. So simply you can calculate it in that way. After calculating IA, just shift the angles by minus 120 and plus 120. Is it clear, Shabab? So this is the calculation of currents. Number C, it was required to calculate the power of the three phases. power can be calculated in many different ways. One of the simplest way is to say power equal to 3 V phase I phase cosine theta. So 3 V phase equal, what is the V phase here, Shabab? Let's go to the connection again. V phase, it's given here VAB. Is VAB the same as V phase or not?
Same.
Same.
Yes,
So we can say power equal to 3 multiplied by VAB, which is 200 volt, multiplied by I phase, which was 20 amps, multiplied by cosine theta. The angle of theta of the impedance was 36.9. So simply we can multiply these values and get the value of 3-phase power. Don't forget to multiply by 3. In 3-phase, you have to multiply by 3. Also, you can apply power 3-phase as square root of 3 multiplied by V line, I line cosine theta. But take care, it's the same cosine theta, not another angle. So square root of 3 multiplied by V line equal to V phase equal to 200 multiplied by I line, which is, we calculated here I line equal to 34.6. Simply when you can apply here, you will get the same value. Also, you can say power in 3-phase, and you know the current in phases, so it's easily to say equal to I square R. Is it right or not? Yani, can I say now the current, the phase current square multiplied by the resistance? Just a moment, شباب. Sorry, شباب. We can say شباب power equal to I square R. Is it right? But here we have to multiply by 3 because it's 3 phases. So what is the value of I phase? Hey, شباب. We calculated I phase is 20 and the resistance is 8. So simply we can say 3 multiplied by 20 squared multiplied by 8. It will give you the same value of power. Okay, this is another way. تمام يا شباب؟ يعني we are going to stop here this class and we are going to continue inshallah by the next class. Any question يا شباب؟
التحضير دكتور ما حضرنا في الشات.
ما ايه؟
في الشات ما حضرنا زي المرة اللي فاتت.
انا اليوم ما خدتش الحضور، مش مشكله، ان شاء الله بدايه من الاسبوع الجاي هيكون في سيكونس جديد بالنسبه لغياب الحضور.
تمام.
دكتور بنروح تيمز.
المحاضرات.
All of the 36 are here today, so we don't need to take attendance.
دكتور بنكون في تيمز الاسبوع الجاي؟
نعم.
بنكون في تيمز.
هبعت لكم في الويك اند ان شاء الله يا شباب، هقول لكم بالظبط